Well guys, till now in this lecture we have discussed about the different type of graphs. We talked about the different type of nodes. Let's talk about the electronic configuration. So the rules of electronic configuration, the first rule is FOW rule. Now this rule says that if we are doing the configuration of any element, then we should fill the lower energy level first, then the higher energy level. So what it's saying, it states that in the ground state of an ion or an atom, electron fill in the atomic orbitals of the lowest available energy levels, then the higher energy levels. And that will be 1s, then we will fill 2s, 2p, 3s, 3p, 4s, and then 3d, and so on. Right? So what is the order? Order is again 1s, then 2s, 2p, 3s, 3p, 4s, and 3d. Now you might be thinking 3d belongs to third shell, 4s belongs to fourth shell. And why the energy of 3d is more than 4s? We find the energy of subshell by n plus L rule, and that is also called Bohr-Bury rule. For an example, if in multi-electronic atom the value of n plus L is same, let's take an example. Suppose we have 4s and 3p. Now for 4s, if we find the value of n, here n is equal to 4, right? And L, that is equal to 0 because it is 4s. So what is n plus L? N plus L will be equal to 4, right? Okay. For 3p, n is equal to 3, L is equal to 1, and n plus L is equal to 3 plus 1, that is equal to 4. Now this is also 4, that is also 4. In this case, we always see the principal quantum number. So 4 is bigger than 3. If we talk about the principal quantum number, then we know that 4 is greater than 3, therefore the energy of 4s will be greater than 3p. Now let's talk about 4s and 3d. So if we take that example, 4s and 3d, we have 4s and we have 3d. So in this case, n is equal to 4 and L is equal to 0. In this case, n is equal to 3, the principal quantum number, and L is equal to 2. So what is n plus L for this? The value of n plus L will be equal to 4 plus 0, that is equal to 4, right? And for this, n plus L will be equal to 3 plus 2, and that will be equal to 5. Now you can clearly see 5 is bigger than 4, that's why 3D will have more energy than 4s. So we will fill 4s first, then 3D. So that was a FOW principle. One more thing I want to tell you, for hydrogen atom, that means having only one electron, and hydrogen-like species like He plus and Li2 plus, that we have already discussed in the Bohr model so many times, the energy of subshells like 2s and 2p, they will be same because there is only one electron, and 3s will be equal to 3p is equal to 3d. So for multi-electronic atoms, we will follow the F-bow rule, that is 1s, then 2s, then 2p, then 3s, 3p, 4s, 3d, and so on. But for hydrogen and hydrogen-like species, the value of the subshells for the same shell will be same, right? Okay, the next rule. Now, this rule says that the pairing of electron in a particular subshell does not take place until all the orbitals are singly occupied. Means, if you are filling the subshell, then you have to fill the orbital singly first, then pairing is possible. For example, if we have d subshell, then we can fill 10 electrons in it. But how we will fill? We will fill one electron, then another, then another. We can't do pairing here, right? Then another, then another. Now, in this case, all orbitals are singly occupied. Now the pairing will take place. Now the sixth electron will come here, right? So this is the rule. Some more points I want to tell you in Hund's rule of maximum multiplicity, and I want to tell you what is the meaning of maximum multiplicity. Now, let's take this case. In this, all the electrons are having minus half spin quantum number. The value of quantum number is minus half, or we can say that they are moving in the anti-clockwise direction. But their total spin, if we add that, half plus half plus half plus half plus half, that will be minus 5 by 2. So if it is minus 5 by 2, the modulus or the value, the magnitude of total spin is 5 by 2, and we are getting the spin multiplicity maximum. So the maximum multiplicity in this case, we are getting 6, that's why it is correct. If we take another case, this one, we have filled one orbital, then we filled another orbital, but we have started pairing here. This is not possible, right? So this is wrong. If in another case, now here you will say that all the orbitals are singly occupied, but here again that term comes, that is maximum multiplicity. Now you can see here, this is clockwise, another one is clockwise, and other three are anti-clockwise. So if we see the total spin in this case is plus half, then minus half, and then minus half. So plus half will cancel minus half, so we will have only one minus half spin. That's why it is not giving us the maximum spin multiplicity. That's why this is wrong. Now, the fourth one. Fourth is Pauli's exclusion principle, and it says that for two different electrons, the set of all four quantum numbers, that is principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number, the set will be or different. It cannot be same. All four cannot be same. Let's take an example. Now, this is 3p and this is 3d. Let's take similar type of electron. Let's take this one, having the magnetic quantum number is equal to 0 and spin is equal to plus half. And this one, having magnetic quantum number is equal to 0 and having spin plus half. Let's see the set of quantum number for these two electrons. So, I am talking about this electron and I am talking about this electron. So, n is equal to 3 for this, and for this also n is equal to 3. So, principal quantum number of both the electron is same. Now, azimuthal quantum number. So if we find out the value of L for this electron, this is p subshell. That's why L will be equal to 1, and here L will be equal to 2. Now, in this case, azimuthal quantum number is different. That's why set of all 4 quantum numbers will be different. Let's take another case. Now, in this case, we will take the 2 electrons having same azimuthal quantum number. Let's take these 2 electrons having magnetic quantum number is equal to 0. So, n is equal to 3 for the electron which is moving clockwise, and n is equal to 3 which is electron which is moving in the anti-clockwise direction. L will be also same because it is p, and for this electron the anti-clockwise it will be also 1 because it is 3p. And if we talk about the value of ml, the value of ml will be equal to 0 for the first electron, and the value of ml will be equal to 0 for the second electron also. But as we know that their spin is different, so the value of ms will be equal to plus half for the first one, and the ms of the second one will be equal to minus half, right? And if you take this electron moving clockwise which is having ml is equal to 0, and this electron which is also moving clockwise, in that case the magnetic quantum number, the value of ml will be different. So it's not possible at all that 2 electrons in an atom or an ion will have the same set of all 4 quantum numbers, right? So these were the rules of electronic configuration. Let's study more about the electronic configuration.